So, a couple of things about our homework that was due this week. So it turns out our function could have been a string function, and which means that we need the std namespace. And what they've taught you so far is to put using namespace std, which works. But there's another way to do that, and that's by using the scope resolution operator, the double colon. We'll learn more about that later on when we start getting into classes and things along those lines. But you'll see it listed in Appendix 2. Basically, in this instance, we're saying for just this one identifier, we're going to say, look for it in the scope of this namespace. So std is the namespace, scope resolution operator, and that applies to the next thing here. Of course, if we do it that way, we'll also have to do it in the definition of our function. And then if we're using string or other words that are defined in that namespace, we can still use using namespace std here. How do I changed that? And then I would have put the text of the message that I'm sending. This time I could just say bottles because that's what I'm calling it here. And then, of course, I would have to finish all of this part to make it actually work properly. I forgot to put the links to our video from last week until today. So if you're using those video links, I apologize for that. If you would like to send me your Gmail ID, I could put you in the C++ student group, and then you'll get a notification when those are available, and you don't have to wait for the link. But I do make a video of each lecture. So if that's helpful to you, send me your Gmail and I can add you. All right. Any questions about Chapter 4? Well, let's carry on to Chapter 5 then. Functions for all subtasks. So I told you before that some languages have subroutines or methods or various other things. Everything is a function in C++. However, sometimes you may want to have a procedure or a subroutine that does not return a value. And the way we do that in C++ is with what's called a void function. And a void function is really just a function that uses a void, the keyword void, instead of a type when we're defining it. And all that means is it's not going to return a value. A void function can still have a return statement in it, but it will not have a value after it. And all that return statement will do is stop executing the code in that function and go back to the function that called it. So there may be cases where it would be really useful to have a return in a void statement. For example, if we want to stop executing the function early, we might put a return statement inside an if that says, oh, this is all we're going to do now, and so return back to our code. Because a function stops executing whenever a return is executed as part of that function. So here in display 5.2, we have a couple of void functions. One called initialize screen, which is basically just putting a new line out to the screen. And one called show results, that's just going to throw out the two values that we've calculated as part of our function. And here's an example of using return the way I indicated. If number is 0, there's really no point in doing our calculation. And in fact, if we executed this next line, we'd have a divide by 0 error, so the premature return avoids that. All right. Let's look at some self-test exercises. Number 1 on page 258 is the friendly function and the shy function. Mr. Gear, you want to take a look at that and tell me what you think the output will be?
It's going to say hello. And then it's going to say goodbye. And it's going to go one more time. And then it's going to end program.
Okay.
Or then it's going to say hello again. Then it's going to end program.
So let's take a look at that. So here's the main code. We call the friendly function. The friendly function always says hello, so that's fine. The shy function is going to compare audience count to 5. So 6 is not less than 5. So it's going to say goodbye. Then it's going to say one more time, call shy again. This time 2 with 2. 2 is less than 5, so it will not say goodbye. It'll say hello again, and then end the program. Does that make sense to everybody? Hello, goodbye, one more time, hello, end of program. Ms. Hargrove, number 2, are you required to have a return statement in a void function definition?
Just in the code, you're not required to have a value.
Yeah, you're not even required to have a void function call. If we left off, unless the logic of the function requires it. So, for example, this return here at the end of show results. Really is not going to do anything. If we just let the code fall through the bottom of the function, it's going to do the exact same thing it would do in the case of this return. So We're not required to have a return in a void function, but we are allowed to have a return in it. And in some cases, it can make a difference in code. All right, and the other thing, that if you read the chapter, Mr. Nelson, number 6, a call to a void function, is that a statement or an expression? Number 6.
Statement.
It's a statement because we're not expecting a value back. If we're using it as an expression, we would be expecting to get a value that we could then assign to some other variable. All right, let's go on to call by reference parameters. When we started making functions, we learned how to make functions that have call by value parameters. And call by value parameters copy the value and the calling argument into the parameter. And it then acts as if it were a local variable for that function. Now we're going to talk about call by reference parameters, which pass a reference to a variable, which basically means we're allowing the function we're calling to refer directly to the memory of the variable that we're passing as the argument. So that's going to be different than what we've been doing so far. With a call by reference parameter, if you change the value of that parameter, since it's pointing to the same memory location that the variable we called it with, the argument, it's going to change the value of that argument. And they show you that on page 262, 263, 264. And then they talk about it some more on page 265 and 266. So basically, this swap values function lets us transfer the contents of the first argument to the second argument and vice versa. So if we call get numbers and input two numbers, let's say 1 and 2, and then we call swap values, first num starts with 1 and second num starts with 2, we then swap them in swap values, and now first num will have 2 and second num will have 1. And if we just said variable 1 equals variable 2, then they would both end up with the same value in them. So we had to have a temporary variable to hold on to one of them while we change the other one. So the argument is the variable that we're calling the function with. That's what we're going to pass to the function. The parameter is the special variable that holds it in the function. In a call by value, we're just going to copy the contents. In a call by reference, we're going to copy the location so that we can actually change the original value. And here's a little program to kind of show you the difference. So they've got this function called doStuff with call by, what call mechanism is the first parameter going to be? Mr. Rahim?
Set up the 7.
No, I'm just asking about this program right here. This parameter, what call mechanism is it using? So I didn't explicitly say when we started looking at this, but the way we tell the compiler what mechanism to use is this little ampersand. So if we don't have an ampersand, it's going to use the value, the call by value mechanism. If we use the ampersand, and if you look in the back in Appendix 1, you'll see that, or Appendix 2 rather, you'll see that the ampersand is the address of operator. That's telling it to use the reference mechanism. So this first parameter is a call by value parameter, and the second one is a call by reference parameter. So doStuff is going to take our arguments and try to do stuff with them. All right, so N1 starts off as 1, N2 starts off as 2. We call doStuff with N1 and N2, which means par1 is going to have a value of 1. Par2 is going to have a value of 2, but it also is referring to N2. So if we change par2, it's going to change N2 as well. We change par1 value to 111, and we can output that. Par1 value in function call equals 111. We change par2 to 222, and it's going to say 222 here. Now we go back and say N1 after the function call is, and what's it going to say?
1.
1, because we haven't changed it, because it's a reference, it's a value parameter. N2 after function call equals, what's that one going to say?
222.
222, because it's a reference parameter, and we changed it inside the function. All right.
So to use call by reference, you have to assign the value in the function. You put it in the main part.
If you call by reference, I'm not sure what you're asking.
Does it have to be? You have to assign the value in the function.
We don't have to assign a value. No, we don't. We're not required to assign it or change it. It's still gonna come in pointing to whatever value was there before. And in fact, if you go back and look at display 5.4, and this function, we do it both ways. I mean, in this program, we do it both ways. So in the first time we call it, those numbers haven't actually been initialized even. So we're actually putting values in them as our get numbers function. Now swap values is going to change them. Later on, we'll have a program where we decide whether or not to change them based on what numbers are in there. So we don't have to change them, but we can. If we initialize them to some value, they'll start off with that value. And when they come into the function, they'll have that value. All right. Ms. Hernandez, what is the output of the program in number 7 on page 272?
$20, $30. And then 1, 2, 3, and then the other item.
Okay. So 10, 20, 30, you say, and then 1, 2, 3, and then you don't know.
Yeah,
All right, so let's take a look at it. So we call figure me out with the values 10, 20, and 30 in A, B, and C. A, B, and C, those are going to go into X, Y, and Z, 2 of which are reference parameters, X and Z, and 1 of which is a value parameter. So from the call, we know that X, Y, and Z are going to start off as 10, 20, and 30. So we output 10, 20, and 30. We now change X, Y, and Z to 1, 2, 3. That's fairly straightforward. We're going to output 1, 2, 3. Now we're going to return from our function call, even though there's not a return statement here. And we're going to output A, B, and C. A went into a reference parameter, which means it was changed when we changed X. So it's 1. B went into a value parameter. So it was not changed when we changed Y. So it is still 20. And C was changed, so it's now 3. So the third output will be 1, 20, 3. That makes sense to everybody? Let's go ahead and look at display 5.3. I'm not 5.3, 5.8. So this is the one I told you about. We call order, which presumably will put first number and second number in ascending order. And yes, indeed, it says if N1 is greater than N2, in other words, they're out of order, call swap values. An order does not itself change N1 and N2, but it does pass the reference on to the swap values function so that it can change them. So if N1 is less than N2 to begin with, this is going to be false, and we're not going to call swap values. We're not going to change the value that was already in N1 and N2. But if N1 is bigger than N2, then it is going to call swap values and change their order. All right. Let's see, it's about 6:45. Let's take a short break and we'll resume in about 5 minutes or so.